Welcome everybody. Today I'm going to talk about how to use your Bitcoin to securely participate in DeFi using a product Coinbase recently launched, cbBTC, a trusted and reputable wrap version of Bitcoin. It's good to see you all. My name is Eli Salm. I'm a blockchain security engineer at Coinbase, a global cryptocurrency exchange and developer platform. I'm a part of the blockchain security team, also known as BlockSec, which is a part of Coinbase's internal security team. We work with other teams in security like application security, infrastructure security, security operations, risk and governance, and more. My role involves working closely with product teams like the cbBTC team, providing security support through design reviews, threat modeling, and ongoing assessments. As a member of BlockSec, I focus on systems that interact and integrate with blockchains. These include wallets, key management systems, nodes, and more. Before I talk about cbBTC and why I think it's the safest form of wrapped Bitcoin today, I want to introduce some fundamental concepts around how a crypto exchange works. So what is a crypto exchange? A crypto exchange is basically a wallet. In fact, it's a collection of wallets. We hold cryptocurrency in these wallets on behalf of our customers because we're experts in secure custody. And not all of our wallets are created equal. Similar to how you would have different financial accounts for different purposes and liquidity needs, Coinbase has different tiers of wallets. Think about it like this. Maybe you have a physical wallet in your pocket with a small amount of cash for everyday purchases. You also likely have a savings account at a bank where you keep the bulk of your funds. We do the same thing. We categorize our wallets into hot and cold tiers, each with different characteristics. Hot wallets are online wallets, connected to the internet. They're used to facilitate quick and easy withdrawals for our customers. Because they're online, they're the most accessible, just enough to meet our customers' needs for immediate liquidity. Hot wallet funds have an insurance policy attached to them to reimburse Coinbase in the event of a loss. Cold wallets are where the vast majority of customer assets are stored. Cold wallets are completely offline, stored in geographically distributed, highly secure vaults. Transactions from cold wallets require multiple approvals from authorized personnel and are subject to rigorous security audits. Observe the diagram in the slide. There are 4 interconnected components. We have inbound hot wallets, we have the outbound hot wallet, we have the cold wallet, and we have customers. When you send money to Coinbase, you're sending money to an inbound hot wallet address. Inbound hot wallets are unique per customer. They allow us to easily identify the intended recipient of a deposit to Coinbase. As you can see in the diagram, funds flow through Coinbase somewhat cyclically. Funds are first sent to an inbound address and then swept to the pooled outbound hot wallet. Funds are then balanced between hot and cold wallets for liquidity needs. Lastly, when funds are taken off platform, they're sent from the pooled outbound hot wallet to a customer. You might be wondering why we pool assets together in our hot wallets and cold wallets rather than assigning each customer their own dedicated address. It's a valid question, and the answer boils down to operational efficiency and user experience. Imagine the complexity of separately managing a cold and hot wallet balance for millions of customers. It would be a logistical nightmare. More importantly, it would likely impact the speed and ease of withdrawals. By using a pooled hot wallet, you don't have to wait for your balance to be restored from cold storage every time you request a withdrawal. This allows for instant withdrawals. However, this pooling means we can't simply query a blockchain node to determine individual customer balances. If we did, we'd only see the total balance of the pooled wallet, not the specific amounts belonging to Alice, Bob, or Charlie. To solve this, we maintain an off-chain ledger that tracks individual customer balances. Think of it as a highly secure append-only database that records every balance update for each user. It's similar to how a traditional bank manages its internal accounting. When you deposit Bitcoin, we update your balance in the ledger. When you withdraw, we update it again. This ledger is the source of truth for your Coinbase balance. Our ledger is a double entry system. This means that every transaction is recorded in two places, once as a debit and once as a credit. For example, when you deposit Bitcoin, your account is credited, and a corresponding debit is recorded in a holding account. This double entry system provides a built-in audit trail and helps ensure the accuracy and integrity of our records. As you can see in the diagram, the off-chain ledger sits on top of our wallet infrastructure. The ledger stores Alice, Bob, and Charlie's balance, while the wallet stack handles the lower-level blockchain operations like transaction signing and broadcasting. This separation of concerns allows us to provide a secure and efficient service to our customers. Now let's dive a little deeper into our cold storage system, which is the bedrock of cbBTC security. When it comes to securing the vast majority of customer funds, we prioritize simplicity and security best practices. First and foremost, we don't rely on smart contracts to manage funds in cold storage. While smart contracts can be powerful, they also introduce additional attack surface and potential vulnerabilities. Instead, we focus on the fundamental principle of securing the underlying private keys. Security of these keys is the security of cold storage. To that end, we don't use third-party software in our cold storage flows. This minimizes our reliance on external dependencies and reduces the risk of supply chain attacks. We've built our own custom solutions tailored to our specific security requirements. Furthermore, we have multiple independent systems that verify the integrity and validity of all transactions as they flow through our environment. This multi-layered approach ensures that no single point of failure can compromise the security of cold storage. Every transaction is scrutinized and validated at multiple stages. Finally, we operate under the principle of don't trust, verify. Our cold storage systems and processes are regularly reviewed by independent third-party security experts. These audits challenge our own assumptions and help identify potential weaknesses that we might have overlooked. In short, our cold storage system is built upon a foundation of simplicity, tailor-made solutions, multi-layer verification, and continuous external auditing. This approach allows us to confidently safeguard the vast majority of customer assets. So enough background. Let's dive into cbBTC, Coinbase Wrapped Bitcoin, a token designed to bring Bitcoin liquidity to Ethereum, Base, Arbitrum, and Solana in a trusted and secure manner. cbBTC is a one-to-one backed representation of Bitcoin, with the underlying Bitcoin held in custody by Coinbase. It allows users to seamlessly and safely utilize their Bitcoin for lending, borrowing, and providing liquidity on various DeFi protocols. Coinbase customers can easily convert their Bitcoin to cbBTC and back again using the send and receive feature, leveraging Coinbase's existing security infrastructure. I'll explain shortly how those systems work. cbBTC is about expanding the utility of Bitcoin and fostering a more interconnected and efficient on-chain ecosystem, all while maintaining the highest standards of security and trust. Since the cbBTC launch, we've been keeping the Bitcoin used as collateral for cbBTC pooled together with the rest of our Bitcoin, primarily in cold wallets. However, we recently built infrastructure that segregates this collateral from the rest of our Bitcoin by moving it to separate cold addresses. We've also created a web page that lists out these addresses and their total token balance. This allows anyone, at any time, to independently verify the collateralization of cbBTC. Beyond that, Coinbase's status as a publicly traded company means that we undergo regular independent financial audits. This means, in addition to our proof of reserves, we provide regularly a public proof of liabilities through our quarterly reporting. In other words, you can rest assured that the Bitcoin backing cbBTC is not being used for any other purpose. I have a video here. There we go. You can visit the Proof of Reserves website at coinbase.com/cbBTC/proof of reserves. On the webpage, under Total Reserves, you can see the total Bitcoin collateral balance. Next to it, under Total Supply, you can see the total cbBTC supply in circulation. And next to that, the supply broken down by network. Below that, you can see the list of wallets holding the Bitcoin. We periodically take a snapshot of this information and publish it on the website. And here I've just clicked an address, and we're in a blockchain explorer, and you can confirm that this address does indeed hold 690 Bitcoin. Depositing cbBTC to Coinbase is designed to be a seamless and intuitive process, leveraging the familiar deposit mechanisms you already use on Coinbase. Let's double-click on what happens in the back end when you create this deposit. First of all, a unique inbound hot wallet address is generated if you don't already have one. Once you send cbBTC to this inbound address, the off-chain ledger we previously discussed credits your account with Bitcoin once the inbound transaction confirms on-chain. On the off-chain ledger, we treat cbBTC as Bitcoin. cbBTC deposits add to your existing Bitcoin balance. Next, the cbBTC tokens you deposited are moved from the inbound hot wallet address to the outbound hot wallet. Another double entry is created on the ledger to account for the fact that this cbBTC is now in our possession and no longer in circulation outside of our platform. Recall how I mentioned that we maintain a balance in our hot wallet based on liquidity needs. If this newly swept cbBTC causes the hot wallet to exceed our risk threshold, the excess cbBTC is burned. A new ledger entry accounts for the reduction in total cbBTC supply. Lastly, if a burn is triggered, Bitcoin is moved back into our pooled wallets from the reserved addresses. This flow is similar to what happens when you deposit Bitcoin to Coinbase, except we're managing cbBTC supply in our outbound hot wallets through burning and minting and the associated ledger entries. Now that you have a Bitcoin balance on your Coinbase account, you'll be able to withdraw cbBTC to a base address, among other chains, to participate in DeFi. As you can see in the UI, sending cbBTC is similar to sending Bitcoin, except you can pick from a wider range of networks to receive the funds. Similar to the deposit lifecycle, withdrawals are recorded on a double entry ledger where all accounts are monitored for discrepancies. The process effectively happens in reverse. We have one fewer step because we don't need to sweep from inbound to outbound. Once cbBTC is set off platform, the customer account balance is deducted from. We also check if there is sufficient cbBTC in our pooled outbound hot wallet, now that some is left. If we need more, we simply mint more cbBTC and lock up Bitcoin in our reserves. A common question in the withdrawal process is, when we mint cbBTC, where does it come from? Well, cbBTC isn't recorded as an additional asset on our balance sheet. Whenever we mint cbBTC, we lock up a corresponding amount of Bitcoin. If all of our customers withdrew their Bitcoin at once, we would simply burn the excess cbBTC in our outbound hot wallet to service the withdrawals. To ensure the security of the entire cbBTC lifecycle, we've conducted a thorough threat model. Before we dive into specific threats we've considered for cbBTC, I want to briefly explain what a threat model is and why it's a crucial part of building secure systems. A threat model is a structured approach to identifying potential threats and vulnerabilities. We systematically analyze the architecture to understand how an attacker might try to compromise it. This involves identifying valuable assets, like the Bitcoin backing cbBTC, potential attackers, and the ways they may try to exploit weaknesses. The goal of threat modeling is to proactively mitigate risks and build more secure systems. By anticipating potential threats, we could design and implement security controls to prevent attacks. This is much more effective and less costly than reacting to a breach after it has already occurred. Now let's talk about some theoretical threats of cbBTC and how we've designed the system to mitigate them. The primary goal of an attacker would be to either A, mint unauthorized cbBTC, or compromise the underlying Bitcoin held in custody. We've already discussed how our cold wallet protects Bitcoin held in custody, so let's just break down the first hypothetical scenario. The cbBTC smart contract plays an important role in the issuance of cbBTC. In order to actually create new cbBTC, we have to sign a mint transaction with a privileged key. The cbBTC contract also stores the on-chain balances held by different addresses. This makes it a high-value target for attackers, so let's consider this contract as an asset that an attacker would theoretically try to compromise as part of this exercise. Let's say the attacker found a vulnerability in the contract that allowed them to mint themselves unlimited cbBTC. The downstream impact of such an attack would be that the attacker may redeem that falsely minted cbBTC for Bitcoin on the Coinbase platform. We can also consider the scenario where the attacker gains access to the keys that administer the cbBTC smart contract. Let's talk about how the smart contract threats are mitigated now. The cbBTC smart contract has been rigorously audited by top-tier security firms and leverages code that has been battle-tested for years in USDC and cbETH ecosystems without a single compromise. We also maintain an active bug bounty program and embrace open source principles. The keys controlling the cbBTC smart contract, particularly those used for upgrades and minting, are secured across a network of multiple secure locations and hardware. Access to these keys requires several context-aware approvals from security experts. This means that even if one secure device is compromised, an attacker cannot gain control of the minting process. The context-aware part is important. Approvals are based on the specific action being requested and its on-chain outcome. For example, minting a specific amount of cbBTC for a specific address. I also want to make a note on monitoring. We've created a detailed threat model for all cbBTC failure scenarios. This threat model informs our monitoring strategy, which is designed to detect and respond to any anomalous activity that could indicate a potential compromise. We continuously monitor the cbBTC smart contract for suspicious transactions, such as large mints or burns, or unexpected balance changes. We also monitor our cold storage system for any unauthorized access attempts or unusual transaction patterns. In conclusion, cbBTC offers a secure and trusted way to bridge Bitcoin into the DeFi ecosystem. By leveraging Coinbase's robust security infrastructure, cbBTC minimizes the risks associated with wrapped assets. The transparent proof of reserve system allows anybody to independently verify the one-to-one backing of cbBTC with Bitcoin. With its focus on security, transparency, and seamless integration with Coinbase's platform, cbBTC empowers users to unlock the potential of their Bitcoin in the world of DeFi with confidence. We're also hiring. I'm here with my leadership, so please stop by our booth, C15. We'd love to chat with you about Coinbase. We have open senior roles within BlockSec, CSERT, Insider Threat Team, Infrastructure Security, and more. Thank you. And I'll take any questions if folks have questions. Oh, okay. Of course.
So imagine that some cbBTC are involved into a scam or money laundering, so you know it. What happens to those tokens? You will not accept it back and you will not withdraw Bitcoins?
Correct.
How do you manage this situation?
Yeah, in the event there is a scam and there's some criminal activity happening on the blockchain, we monitor this. We're working with law enforcement agencies, and we have the ability to prevent folks from depositing or withdrawing funds. So even if they do deposit funds, we can lock their account for suspicious activity.
And what do you do with the locked Bitcoins?
Well, once we only unlock the Bitcoin if we burn cbBTC, and so if we go through a full investigation, we do due diligence, and we determine that this person is, acting is a criminal, then we can, revoke their balance and then burn the cbBTC, and that would allow us to unlock that locked Bitcoin. Does that make sense? Thanks. Any other questions? Great. Thank you so much.